Introduction to Programming Paradigms. Procedural programming, simplicity and structure.
Procedural programming focuses on a series of instructions or procedures. Its main advantages are logical flow, simplicity, and ease of understanding, making it ideal for beginners and straightforward tasks. Structured code using routines or functions makes maintenance and debugging more manageable.
Object-oriented programming, modularity and reusability.
Object-oriented programming organizes code around objects and data. Its strengths include code reuse through inheritance, easy scalability, and better organization with modular classes. This approach encourages encapsulation and abstraction, making large, complex systems easier to manage and extend.
Functional programming, predictability and testability.
Functional programming emphasizes functions without side effects and immutable data. Its key advantages are improved predictability, easier debugging, and simpler concurrent code. By focusing on pure functions, functional code is often more testable and less prone to unexpected bugs.
Other paradigms, flexibility and specialization.
Additional paradigms, such as logic and declarative programming, offer benefits for specific problem types. Logic programming is powerful for solving complex logical puzzles, while declarative approaches excel in expressing what needs to be done, not how. Combining paradigms can create flexible solutions tailored to various challenges.
Choosing the right paradigm.
Each programming paradigm shines in different contexts. Procedural offers simplicity. Object-oriented excels in organizing big projects, and functional is robust for reliability and testing. Understanding these strengths helps programmers select the best approach, often mixing paradigms to leverage the advantages of each.